Thanks for joining me for this video. I'm going to do a quick introduction of a greatest common factor and how to factor that out of a polynomial. So a greatest common factor is the largest number or polynomial that divides evenly out of each term of a polynomial. So you're looking for what they have in common. That's why it's called a greatest common factor. So what do they have in common? So we're going to do two things, and I wanted to give the directions for both of these things because students often get confused with the directions. If it only asks for one, they're not really sure what to do. Stating the GCF is first, so I'm just going to state it first. State GCF, and I guess I don't need to write state. Let's just write GCF. GCF. That means, what do these two things have in common? What could I divide out of both of them? So maybe you see it already, maybe you don't. You can divide them both by 2. If you're not sure, you can write them as factors. So let's say you write 8 as 2 times 4, which is 2 times 2 times 2, okay, with an x. Minus 10 is 2 times 5, and that's as much as you can break that down. Notice that they have 2's in common. So that's going to be your greatest common factor. That's the only thing that they have in common. So the greatest common factor is 2. And you may be able to just see that looking at them, right? You can say, oh, I can divide 8 by 2 and I can divide 10 by 2. What I would suggest doing is going ahead and dividing. So if you think it's 2, great, then divide them both by 2. So what you would do is you would write 2 down, and then you would divide and see what's left. So 8 divided by 2 is 4, so 4x. Negative 10 divided by 2 is negative 5. Now look inside your parentheses and see if you still have anything in common. So do 4 and 5 have a common factor? Could I take anything out of both of those terms? The answer is no, right? And so since I can't take anything else out, this would be factoring out the GCF. So this is the blue. So if it just tells you to state the GCF, you're just telling what they have in common. If it tells you to factor out the GCF, you're going to write down what they have in common first, and then open parentheses and tell what's left if you divide that out. Remember that what you're writing, what I just wrote in blue right here, is equivalent to my original expression. Those two things are supposed to be equivalent. So if I distribute that 2, I will get back to 8x minus 10. So they're the same thing, just written in a different way. So let's look at number 2. What do these have in common? What is the GCF? So I think the GCF is 3. And then I also see that they both have an x in common. So I'm going to say the GCF is 3x. So I'm going to divide 3x out of both. So you write the GCF first, open parentheses, and then state what you have left after you divide. So 15 divided by 3 is 5. X squared divided by x is x. Plus 6 divided by 3 is 2. The x's cancel. 5x and 2 have nothing in common, so that was the GCF. All right, number 3. We're going to state the GCF first. Okay, so let's say I think the GCF is 3. Okay. Now, it's not. I'm going to get it wrong on purpose, but let me just show you something. Let's say you thought it was 3, or let's say you thought it was 10. I mean, either way. Let's say you thought it was 10, and you divided them by 10. Notice that 6 and 10, 6 is not divisible by 10. So right there, you should know that you made a mistake. If whatever you say is the GCF does not go in evenly to what you have, that's not correct. Right? So GCF. 2 will go into both. So let's say I think it's 2. And then always remember to look at your variables. They both have an x. So this one has an x cubed and this one has an x squared. That means that this one is x times x times x, and this one is x times x. So you're looking for what do they have in common, or how many do they have in common? Do they both have 3? No. But do they both have at least 2? Yeah, they both have at least 2. So you're going to put an x squared here as your GCF. So your GCF, your greatest common factor, is how many they have in common, and that's always your lowest exponent. So for your y's, you have a y to the first and a y cubed. The lowest exponent is 1, so that means they both have at least one y. So that's my guess. So I'm going to divide by 2x squared y. Remember that when you're factoring out your GCF, you write your GCF first, open parentheses, and say what you have left after you factor or divide that out. So 6 divided by 2 is 3. X cubed over x squared is x. Y's cancel. Minus 10 divided by 2 is 5. X squares cancel. Y cubed over y leaves y squared. So now I'm going to look in the parentheses to make sure I don't have anything in common. The 3 and the 5 do not have common factors. The first 3x has an x but no y. And the second one, the 5y squared, has a y but no x. So perfect. They don't have anything in common. So that's it. All right, number 4. We want to know what the GCF is. So a 5, a 10, and a 5. So it's going to be a 5. If your first term is negative, it's common practice to divide a negative out, just so that your first term is positive. So we're going to divide out a negative 5 instead of a positive 5. And then how many x's do they have in common? So we have a 7, a 6, and a 5 as exponents. Always take out the smallest exponent. So they all have at least 5 x's. So we're going to say x to the 5th. So I'm going to divide by negative 5x to the 5th. I'm dividing that out of every term. I'm going to write my greatest common factor first, and then open parentheses and see what I have left if I divide that out. So the negatives cancel, the 5's cancel, x to the 7th over x to the 5th. 5 of the x's from the top will cancel with the 5 on the bottom and leave x squared. Negative divided by negative is a positive. 10 divided by 5 is 2. And then x to the 6th over x to the 5th, there's only one x left on the top. And then the last term, a positive divided by negative is a negative. 5's cancel, x's cancel. So what does that leave me? A lot of students will make a mistake and just say, oh, nothing, and they'll close it after the 2x. But remember, when you're dividing out, it's dividing and leaving ones behind. So this is a 1. You always should have the same number of terms in your parentheses as you had originally. So if you start with 3 terms, parentheses should still have 3 terms left. If I check, I see that the stuff in the parentheses, there's nothing in common. So there's my answer. So again, the red is just stating the GCF. The blue is the process of factoring out the GCF. And what that means is divide out the GCF. All right, the last 2 examples. So number 5, GCF. So 12, 5, and 8. So maybe you thought 2, but 5 is not divisible by 2, so that won't work. There is no number that will divide out of 12, 5, and 8 evenly. They don't have any common factors, so no number. What about x's? Do they all have an x? No, the 8 does not, so you can't divide out an x. The only thing you can really divide out here is, I notice that the first term is negative, so you really want to get used to dividing that out. So I would divide out a negative 1. So if I divide out a negative 1, that's just going to change all the signs. The 2 negatives make a positive, so now I will have positive 12x squared, negative 5x, and positive 8. If you don't want to write that 1, it's really better if you don't. it would look like this. That 1 is understood to be there in front of the parentheses. And so that would be what you would get if you factored out the GCF of -1. Number 6, this one looks a little weird. So what do they have in common? So what you want to notice here is that this is considered one part and this is another. Notice that the x minus 2's are in common to both parts. That is going to be your GCF. Okay, so you can divide out an x minus 2 from both parts. And what happens is that those will cancel out. So if I'm going to factor out the GCF, I always write the GCF first, right? And then I open parentheses and say what's left if I divide that out. So the x minus 2's cancel and just leave x, right? Plus the x minus 2's cancel and just leave a 4. And that would be the factored form of number 6. It looks strange. You will see this again when we do factor by grouping, because we're going to use this idea over and over when we do factor by grouping in a future section.